I am Pranati Purohit. I welcome you back all the participants to the session of short-term course Power Quality Converters for Green Energy and EV Integration. Now the present session talk will be delivered by Professor Suman M, IIT BHU on the topic Unintentional Islanding Detection Methodologies. Let me introduce you all to Professor Suman M, sir. Professor Suman M received the BE degree in Electrical and Electronics Engineering from Tech affiliated to Anna University, Chennai, India in 2012, MTech degree in Power System from the Motilal Nehru National Institute of Technology, Allahabad, India in 2014, and the PhD degree in Electrical and Electronics Engineering from the National Institute of Technology, Tiruchirappalli, India in 2019. He worked as a research associate 1 at the Indian Institute of Technology, Kanpur from 2019 to from March 2019 to May 2019. He worked as an assistant professor in the Electrical Engineering Department, Motilal Nehru National Institute of Technology, Allahabad, India for around 4.5 years. Currently, he is working in the Indian Institute of Technology, BHU, Varanasi. His research interests include unintentional islanding detection of microgrid and the power system protection. He is serving he is having 7 papers in reputed journals and 10 national international conference publications. He is having government funded projects worth rupees 2 crore. He is serving in the technical as a technical reviewer for several reputed international journals. Now I request Professor M. Suman sir to deliver the talk. Over to you, sir.
Yeah, thank you. Whether my screen is visible?
Your screen is visible, sir. Slides are not visible.
Just slowly.
Yes, it is visible.
Myself, Suman. I'm not a professor. I'm Suman. So my presentation is going to be on unintentional islanding detection methodologies. So before going to the content, let us see the outline of the presentation. Are you able to see the outline of the presentation or still in the title slide?
Yes, when we can see your outline slide.
Okay, fine. Thank you. So this is the outline. So before we go to the complete presentation, let us start with the basic structure of our system. Why do we need microgrid? That we need to discuss before we are going to that. Then what are the challenges that we will be discussing? So before that, we will be starting with the basic structure of power system. So generally, we, the consumers or customers who will be at a very far distance with respect to the generating power station. So this generating power station nowadays it is centralized in nature and it is having a very huge power capacity, right? So that is a very huge power capacity. Now, when we are having this generating station at a far end, that power generated, which is generated in the centralized power generating station, need to be transferred from that particular location to the consumer end. So when this power is being transferred, then that is transferred at a higher voltage and it is distributed at a lower voltage. That power is transmitted at a higher voltage because we need to reduce the transmission losses. Now, when it comes to the distribution, we are reducing the voltage according to the requirement of the consumers. Now, what are the problems exist in the centralized power generating station? We know that this centralized power generating station, since even though we are in 2024, still we are using more than 60% of the power generation using thermal power station. So when we are using generating power in this kind of thermal power station or coal or nuclear power station, here we are going to have some hazardous gases which is going to be emitted by it. Then the second thing is these kind of sources are fossil fuels. So because of this reason, this fossil fuels are ever diminishing in nature. So after a few years, we may not get coal, or even sometimes now also we are getting shortage of coal for some days. So this is going to be decreasing. Also, it is going to emit some harmful gases. The second problem with the transmission system is since we are transmitting over a longer distance, even though we are stepping up the voltage, we still have a significant power losses. As per Power Grid Corporation of India, at the year of 2021, still we are having a power loss of 21 percentage within India itself. That 21 percentage is that 21 percentage is only because of the transmission losses. So now there are two main problems we have seen. One is this fossil fuels, and it is dangerous. Where the process of obtaining these fossil fuels are dangerous in nature, and it is going to pollute the environment in one or another way, and it is going to be diminishing in nature. Now, already we have talked about this transmission over a long distance, longer losses. Now the losses are increased. Now, if the demand is increasing, you know that already our demand, electrical demand from the consumer side is keep on increasing. But we have already have a fixed transmission infrastructure. If we wanted to meet the increasing demand, there are two ways. The simple thing is you can have a new transmission infrastructure which can be placed parallel to the existing infrastructure. So what is the problem in this is when we wanted to develop a new transmission infrastructure, it needs a huge capital investment. So we need an alternative instead of going for a huge capital investment. Okay, so then the third problem is reliability is less. What is the meaning of reliability? I wanted to say here is, see, you can see here in this basic structure of power system, we are the consumer, we are here, we are here. So let's say that if there is some problem in the distribution substation, or if the distribution substation needs to do some maintenance work, then what happens is the continuity of power supply is affected to the consumer end or the customer end. So the reliability mentioned here is representing the continuity of power supply. So this is a radial system. In a radial system, if there is some maintenance event happen in the distribution substation, obviously the customers and the consumers will not be getting any power. So we wanted to overcome all these drawbacks or shortcomings. If we wanted to have an alternative so that we can avoid these drawbacks in this work, the very simple thing which we can do is supplying power at the customer end itself. So this customer, if he is or she is capable of generating their own power, if they are able to supply their own demand or to the nearest demand, whichever is possible for them, then what happens, you can see very clearly the power required from the transmission system is reduced. If the power required from the transmission system is reduced, obviously the power loss in the transmission system is also be reduced because it is represented as I square R. So this I square will be reduced. Because of that, the losses also will get reduced. Second thing, when we are talking about the power generation in the consumer end or customer end, here we are going to deal with the renewable energy sources. See, generating power in the consumer end is not new to us because from very long time we are generating power using diesel generator, or we are generating or we are supplying power using UPS to our computers. Those are not new to us. But the thing is, when we use a diesel generator, that is not a renewable energy resource. And when we talked about the UPS will be charging during the time when the grid is there. When the grid is not there, the UPS will be supplying the computer. So now we need something which can supply power without affecting the nature. One such thing is the generating power using our renewable energy resources, which is solar, wind, fuel cell, like that. So now this power generation at the customer end is solving all the problems which is mentioned here. So here we are going to deal only with the renewable energy resources. So if we are dealing only with the renewable energy resources, all these problems will be gone. Then transmission over the longer distance, that is also reduced because the power required from the transmission network is going to be reduced. Because of this, the losses will also be reduced. Then the infrastructure, since we are able to supply the power in the customer end itself, then the existing infrastructure need not to be modified, or a new infrastructure need not to be developed, so that we can avoid the huge capital investment. As I said earlier, the reliability is less for the conventional power system, but since we are generating power at the customer end itself, our reliability will be improved. The term reliability mentioned here is the continuity of power supply. Okay, so now this particular power generating at the distribution end, that is a distribution system, we are going to call it as a distributed generation. So when we are calling it as a distributed generation, here we are going to generate at a very lesser power capacity when compared to the centralized power generating station. Let's say in centralized power generating station, we are generating power at the rate of at a power rating of 600 megawatt or 700 megawatt. Here we are going to generate power at a very smaller rate, like 50 kilowatt or 100 kilowatt, or even from 10 to 20 megawatt, let's say. So here the power generating capacity is being distributed completely. Okay, so because of this, this is called as distributed generation. So the distributed generation means the overall capacity is being distributed as a smaller units. Okay, so this will be ranging from a very few kilowatts to some 40 to 50 megawatt. Till that range, we can generate power. So now the energy resources which are used to generate power, which may be based on solar, wind, fuel cell, or biogas. That is of very smaller scale generating sources that I have already told. So this is located at our near to our home, and this provide an alternative for the conventional power system. This overcome all the shortcomings in the traditional electrical power grid. Okay, so now we have talked about this distributed generation. The advantages also we have discussed. So it reduces the transmission losses significantly, and the fuel which is used for generating power in this is eco-friendly in nature, and it improves the reliability and resiliency. So resiliency, we do not talk about that right now. So it improves the reliability. Here I wanted to talk about the reliability means the continuity of power supply. Also, it avoided the new transmission infrastructure. So it is less expensive. We do not need to develop a huge infrastructure for the power transmission for the increasing demand. Okay, so these are the advantages which offered by the distributed generation. So we need to include this distributed generation. Okay, we need to include the distributed generation within our system. So you can consider that these are DGs. DGs means distributed generators here. So this DG is having the solar, wind, or biogas, whatever it may be. It needs certain converters. Let's say that PV is a solar photovoltaic. It is a DC power generating unit. So it is need to be connected to the microgrid or the grid. We will talk about the microgrid. It need to be connected to the grid. So when we wanted to connect it to the grid, then the DC output power need to be converted to the AC. So for that, we need some associated converters which perform this action. So along with the converters with the distributed energy resources, we can call that as a distributed generator. So there are multiple distributed generators which can be connected in the system so that distributed generators can be supplying the loads when the grid is not there, also when grid is there. Okay, so now we will talk about microgrid. Microgrid is nothing but a set of loads and generators connected in parallel, and it is capable to supply the loads in grid connected mode, also in islanded mode. We will talk about grid connected mode. So here, this microgrid is a combination of several generators and loads that is capable of supplying power to the loads and the in the grid connected mode, also in the islanded mode. So this microgrid is going to have a clear electrical boundary. So that is mentioned in this green line. So this microgrid is going to have a clear electrical boundary. So this can just supply or it can take the power whenever it is required from the grid. Okay, now we will talk more about this. So microgrid, the proper standard definition is it is a group of interconnected loads and distributed energy resources within a clear electrical boundary. So if you are seeing from the grid perspective, this microgrid is considered as a single controllable entity. Then this microgrid can be connect or disconnect from the utility grid, and it can operate to supply the power or take the power from the grid depending on the requirement. So now this is two standard definition. One is given by US Energy Department and second one is given by SIGRI. So both are very standard definitions. All are almost remain the same. There is no much difference in the definitions. So the microgrid. So let us talk about the microgrid. The microgrid can be operated in two modes. One is grid connected mode and the second one is islanded mode. So consider that, as I already said, whichever is given in the green dotted line, that is a clear electrical boundary. So now you can see if these are circuit breakers. If it is red in color, it means that it is closed in condition. If it is green in color, it is open in condition. So this is a grid connected mode of operation. During the grid